Hello, everyone, and welcome to the AI Talk series with NeuTigers. I am Stan Bertolut, VP of Growth here at NeuTigers. NeuTiger productizes and commercializes exclusive IP, AI IP algorithm from Princeton University. We enable smart application at scales for the intelligent edge network in the healthcare, industrial IoT, and cybersecurity sectors. In a recent report, the consulting firm Transforma Insights predicted that there will be over 21 billion deployed AI instances by 2030, up from 1.8 billion in 2021. And over 99% of them will be associated with the Internet of Things. Cloud deployment are eventually overtaken by edges. So given the edge AI positioning of NeuTiger and the growing interest for edge AI, we wanted to dive deep into this timely topic. I already see quite a few people connected and streaming today. I will be interested to hear from you. So please tell me using the panel where you're streaming from today. So here with me to talk about AI and IoT, Matt Hatton is the founding partner of Transforma Insight, the leading advisor on IoT, AI, and digital transformation. Matt is a well-respected commentator and technology industry expert with over 20 years of experiences at the cutting edge of technology research and consulting. Previously, he was the founder and CEO of Machina Research, which was acquired by Gartner in 2016. On the NeuTiger side, I am joined by Vishu Ghanakota, our CTO. Vishu has 20 years of technology experience working with lean startups and agile technologies with a focus on software and mobile app development. He is an expert in cloud and app analytic infrastructure. He has authored numerous patents focused on analytics data collection. Previously, he founded Introspex Inc., a mobile app insight platform. So welcome to the AI Talk series, Matt and Vishu.
Hello, good to be here.
Nice to meet you, Stan.
So let's see. So yeah, guys, remember to tell me where you are streaming from. I think we would love to know that. But in the meantime, we thought that in order to talk about this interesting topic, we would focus on 5 areas: object detection in closed circuit television, autonomous driving, utility grid monitoring, and obviously what's going to be of interest for everybody, it's the ROI on IoT. So again, this is a live event and feel free to participate. Jump in at any time with a comment, a suggestion, or a question. Use the side panel, whether you are streaming from Twitter or from YouTube. Matt and Vishu, do you want to add a word about yourselves?
Just very quickly, in the interests of getting the ball rolling on where people are calling in from, I'm calling in from the UK, based here just south of London. But other than that, I think you summed it up pretty well in your intro. I'm a technology industry analyst, now getting close to 25 years of experience. Ooh. So that's quite terrifying. Around about November time, that'll be me with 25 years experience. So there we go. And yeah, very excited to join you today. Talk about IoT, AI, and edge.
Fantastic, Vishu.
Sure. Yeah, my experience has been I've spent close to 20 years now building complex event processing systems, monitoring systems, essentially whether they are software-based systems using software sensors or human bodies using wearable sensors, and industrial systems using physical sensors.
Excellent. All right. So Matt, for those of us who are less knowledgeable about IoT, would you say a word about what it is and why is AI so central to IoT?
Okay, so we could probably spend hours and hours discussing what is the IoT, but very simply put, Internet of Things, it's a mechanism for, or it's a set of technologies that kind of sits under an umbrella, but those technologies are tasked with monitoring and controlling physical items. So you use it for sensing the environment or controlling physical assets remotely, meaning you don't have to send a person to go deal with them. But it gets a lot more complicated because effectively it's something of a continuum, because the starting point with IoT was, how do you monitor something? How do you check how much rainfall there was in the place, or how many cars there are passing a point? And then it moved progressively on to control. Okay, industrial control systems. How do you remotely manage a factory or some other kind of process? And the natural evolution on from that is effectively onto some element of autonomy, which might seem counterintuitive because from the sort of telemetry to the telematics to the IoT control, you're gradually taking more and more control centralized, and effectively with AI, what you're doing is you're putting it out to the edge, and with edge compute as well. So these three technology areas all are very closely interlinked. If you want much faster response times and effectively just a better capability in an IoT solution, often it's best to be done with some element of autonomy. So you need to put some form of machine learning, some form of AI onto the edge device, and then you need more processing there and so on. So you effectively have these three technologies that are three legs on a stool, really.
Right. And Vishu, Edge AI is what we do at NeuTigers. A word about Edge AI.
Sure. And as Matt mentioned, there is some confusion around what constitutes IoT or Edge AI. When we talk about Edge AI, are you talking about application edge or device edge or network edge or a cloud edge? So there's a continuum here as to where the knowledge or where the data is being processed. So that defines the edge. And there is also a great deal of continuum of algorithms, the level of sophistication required in these devices that goes from application edge running on a device versus cloud edge, and the considerations for deployment, the considerations for the level of autonomy, there's a lot of difference in where the data is being processed.
Right. Matt, you kindly agreed to share with us and with people watching this event slide from a recent webinar. Would you like to say a word about what really struck you when you gathered all your research to produce the Forecasting Artificial Intelligence Market Report 2021-2030?
Yeah, happy to do that. A bit of background.
Sure.
So Transforma Insights, we've historically, well, I say historically, we've only been around for 2.5 years, but one of our core areas is IoT market forecasting. So we typically take a highly granular approach to that, looking application by application, country by country at identifying the market opportunity associated with IoT. And we figured we'd do the same thing for AI, apply a little bit of rigor to looking at this market bottom up, looking at where AI is deployed, looking at what we term instances of AI, rather than trying to identify the revenue or some kind of financial measure in there, which is kind of challenging. And I'll touch on that a little bit in a while. But we thought, okay, we'd look at the instances. Where's it deployed? Where have you got some sort of algorithm processing or being applied to data? And the interesting thing was, you mentioned a few interesting points, but the first one you mentioned was this effectively tenfold growth in the use of AI over the next decade. Perhaps not super surprising, I wouldn't say. That's probably within the margins of expectation of most people. We see a lot more AI being used. But beyond that, the key thing was that 99% of AI was being used in IoT, was being deployed in the Internet of Things. And I should probably explain why we looked at instances rather than revenue. Instances are for us rather more interesting because revenue might mean a number of different things. Well, first of all, how do you measure it? Is it how much a company spends on deploying AI? In which case, if they do it inefficiently, then that's more revenue, and if they do it efficiently, then it's less. So, it's not an ideal way of looking at it. Similarly, if you're an organization, you could look at it, from the perspective of the efficiency savings or the benefits that come from it. But increasingly, AI will be table stakes. I hesitate to use the term, but it becomes just part of the fabric. And so effectively, if you're an organization that's deployed AI, you're just keeping up with every other organization that's done a similar sort of thing. So it may have no impact on revenue unless you're the poor company that's decided not to do it. So this was the motivation for looking at it that way. A couple of other things I'd throw in that we found interesting within that IoT dominated AI. There's a lot focused on consumer electronics. It's the interface between people and machines, and that's really where AI seems to be finding its strength, or at least the bulk of the capabilities that are sitting. It's in things like natural language processing and chat bots and so forth. So that we found quite interesting. And there's
Matt,
sorry, jump in.
Quickly to interject there. By the way, for everyone listening, it's a great report. I highly recommend reading through that report because it gives a comprehensive perspective on how to look at this. It's been one of the difficult industries to understand, particularly when you throw in AI. Like what are the ways of looking at it? One of the items that jumped at me was that eventually the cloud deployments are expected to overtake the edge. I would have guessed the other way around, given the ubiquity of edge devices and the forecast. Can you shed some light on that particular aspect of the report?
Yeah, it's really a function of the dynamics of the individual applications that we look at. So there's no overriding trend that kind of pushes it in that direction. It's more that things like the adoption of certain use cases which are based in the cloud start permeating down through more organizations. Okay, so there's certain quick wins with edge type deployments, and there are certain use cases where you would expect AI to be almost automatically deployed, and then you start getting to the point of having relatively mature levels of deployment there. So take, for example, CCTV cameras. Okay, right. So increasingly CCTV cameras will have some form of AI on them to do, even if it's something as basic as automatic number plate recognition, right? And when you get to the point of 100% penetration of those devices, well, then you bump up against a quite severe limit. But you will get this gradual growth of a lot of those applications that are cloud-based, that are relevant for almost every organization, and it will gradually permeate further and further into more and more organizations, rather than just being the limit of the sort of Fortune 1000 companies, or the big organizations, which tend to be the ones that use it today. So it sort of democratizes that, which is why you get this effect.
Right. Let's jump into the board of the discussion here, talking about CCTV's images. And Matt, cameras are everywhere, right? Mm-hmm. They're in the streets, they're in our car, they are in manufacturers, they are even the eyes of robots. Talk to us about CCTVs, and what is the impact of this market on this entire AI IoT sector?
Yeah, happy to. I mean, it's worth noting that the image recognition type capabilities that we look at in CCTV are relevant for a whole bunch of other applications as well. But thinking about CCTV, you think about the main way in which people sense the world. interpret the world, and visual is clearly the number one. It's more important for me to be looking at you, perhaps. Mind you, a few years ago we might have been doing this as an audio call, so maybe it's a moot point. But my feel for it is that visual is clearly critical, and there's an opportunity for a lot of use cases, almost for a generational leap. You know, you don't have to implement a whole load of sensing and monitoring devices if you can put in cameras around, say, a factory to identify, okay, well, this is clearly the problem where the bottles are dropping off the production line, or where there's leaks or various issues. In fact, you could stick a camera on if you've seen the robot dogs that were very popular at Mobile World Congress last week. You can stick a camera on that, and it can go around and effectively act as a sensing device that's movable and can replace a lot of the other sensing devices. And you know, you can learn an awful lot from video images. You've got a whole series of increasingly sophisticated ways that you can use video or image recognition, video recognition. I mentioned ANPR as probably the most basic. You turn a video stream into a set of 7 or 8 characters and send that. Pretty basic stuff, all the way through to identifying whether somebody is shoplifting, or indeed in Amazon stores, allowing them to pick stuff off the shelves and just walk straight out the door with it. It just has that flexibility that you try to replicate that with other forms of sensors. It's going to be very, very challenging to do. So it's just sort of replicating what people do, I guess, is the way of thinking.
So yeah, I guess as an anecdotal information here, half of our brain's neurons are dedicated to visual processing. So that's one of the major areas of how we sense the world. So it's kind of makes sense that we try to replicate that in the devices that we use.
And Vishu, is image processing on the edge already a reality?
So that's a great question. What we see is that a number of use cases that range in continuum from collection of data in front to the cameras, all the way to one of the difficulties with edge image processing is that they tend to be the most energy and processing intensive applications when it comes to AI. And that's one of the reasons. And they also use a lot of bandwidth. If you were to do this over cloud, they're going to end up taking a lot of your bandwidth and energy in transmission. So it might be more efficient to process them, reduce them on the edge itself. And that presents the challenge that how do you reduce the size of these algorithms so that they can be processed efficiently on the edge. And that's the intersection where we work on to try to bring the reality of processing more and more of this data, particularly image data, on the edge, so that we can not only save on the processing, we can also save on the bandwidth. Believe me, even with 5G rolling out, all the bandwidth in the world is not going to be enough if we start sending images, every single images that these devices are capturing over to cloud. So that's just not practical. The image IoT AI processing, at least inference, there are 2 categories. You could either learn or train on the edge, or you could also do just inference on the edge. At least the inference on the edge is where we see more and more applications, and we see a lot of customers asking or showing interest in those applications.
I was going to jump in around the 5G question, Vishu, actually, and not least because I was at Mobile World Congress last week and talking to a lot of people about anything related to mobile technology. So it strikes me as interesting the idea of varying levels of latency. So historically, it used to be the access network that was the pinch point. You know, that was where you got the high latency, whereas the core network, the fiber essentially
Right.
caused not a lot of an issue, whereas in a 5G,
the last mile,
so but with 5G actually it becomes the core network that's the issue. So
right.
we see an interesting dynamic with putting more data center, more processing capability actually at the edge of the network. So this concept of mobile edge computing or multi-access edge computing, depending on how you want to term it. You seeing that as well?
Well, absolutely. In fact, we ran into an interesting startup at CES in January here in Vegas. That I'm on the West Coast. That's why I used the word here in San Diego. What we see is that just as developers are used to deploying their applications on the cloud, on a public cloud like Amazon's or Google's, the network providers are now, there is a market opportunity to deploy your applications on the network edge just to make use of the available bandwidth and to avoid the problems that you're mentioning there. For developers, once you open up to the Kubernetes, the modern way of managing applications, it doesn't matter whether you're deploying your applications at maybe 200,000 of network locations or maybe 20 of your Amazon regions. You have to have automated deployment, automated processing anyway. So you might as well install on the network edge to make use of the bandwidth and also save on the bandwidth on the upstream where you may be more constrained. One good example might be that if you have a large hospital system, you could deploy your applications right there on the network edge. And for application developers, it's pretty seamless, whether you're deployed on your Amazon cloud or whether it's localized to the hospital cloud. They work, it's the management, the deployment, or they are all the same. And for the users on the hospital side, they're connected to the network. It's still going through their systems, so their experience doesn't change. Just that you get the savings, all the processing, data reduction, and AI is done on the network edge, saving the bandwidth on the upstream. So that's a great application. We are seeing more and more of that. But it's early on, as you understand, the established network players are pretty strong. So the adoption might be slower. There are new challenges in this area that are challenging this established model, but that's where we see the world moving to.
Yeah, but it does give you a bunch of different options, and I guess in a way it creates perhaps a headache in terms of architecting because you've got all of these additional extra options. But you know that's always been the way, right? You get new technologies come on stream. You've got to start balancing them, but ultimately it's all going to be useful for somebody or some kind of deployment. Yeah.
Right. The adoption of Kubernetes for application deployment and management has revolutionized that way because now it automates the management of applications. So whether you have 50 Amazon regions or 500,000 network edges, you're going to be using the same tools, same technology to manage that infrastructure.
All right, let's move on to autonomous driving. And self-driving vehicles cover pretty much every aspect of AI and IoT, right? Vital computation must be done on the edge. Cybersecurity is essential since no one wants to see their car being hacked, obviously. Car must be autonomous, yet able to communicate with one another and with other devices. And they must also monitor passengers and drivers. Matt, are autonomous driving, or is it really one of the largest sector when it comes to AI instances? And what can you tell us about it? How mature is it?
Very immature, I think we would say. It's certainly one of the applications that everybody's interested in talking about. Clearly, in the long term, it will have one of the most significant impacts on how people live and work. But the reality is, even by 2030, it's still pretty small. I think I did check before I jumped on this call. Number 15 in terms of the scale of AI on that list, and it's pretty far down, well below a whole bunch of other device types. There is some movement, you had quite a big year in 2021, or we had quite a big year in 2021. Honda was first to market with a level 3 automation, Mercedes just behind them, which allows for low speed automation on freeways, motorways, call them what you will. But you're looking there at vehicles that are in the $100,000 plus price range. So clearly not every vehicle. And it's certainly not full automation. And to get to the level 4, level 5 type automation, well, you're going to have additional costs associated with that. And I think the car industry's come to the conclusion that perhaps level 4 isn't really that valuable, other than maybe for platooning for trucks, and therefore it's level 5 that you're really looking at. So there's a whole lot of there's a couple more generations of technology to be developed, but it's not really entirely the technology. In fact, very far from entirely being the technology. You've got regulation associated with it. You've got issues of liability and various other things like that. Funnily enough, it always seems to me that that Tesla's always 2 years away from automation, but that's something that always strikes me. And there's one other thing I'd mention. So you regularly get new regulations coming in, and there was one in the EU just recently about emissions. And obviously there's a weight element to emissions. Lighter the car, the lower the emissions. And therefore, if you make the car heavier with all this additional capability, you have to be sure that somebody's going to be using it. You can't just have a "if you build it, they will come" type approach, and you otherwise will fall foul of the rules. And so there's constantly these hurdles cropping up, and as you can tell, our expectation is by 2030 we won't see anything that's substantial on passenger vehicles. Now, commercial, certainly commercial in terms of where you have private areas. So, for instance, mining, a mining site, or on a campus, there's certainly uses there. Delivery robots. It's going to be thousands, hundreds of thousands of delivery robots. So that those two things in their own right are also autonomous vehicles. But in terms of changing the way that we get behind the wheel, I think it's a few decades off still.
Right. So Vishu, as we just heard, autonomous cars are not there yet. What do you see when it comes to car manufacturers? They are looking at edge AI for the security and well-being of their driver, right?
Yeah.
What are they working on?
Right. So, as Matt mentioned, when we talk about autonomous cars, the autonomous part gets a lot of focus and attention because it's exciting. But short of full autonomy, there are a lot of applications for edge AI that are quite exciting, equally exciting, I would say, at least from a technical point of view, and that are being deployed right now. In fact, if you're driving a later model car, it's quite likely that you're actually using a lot of connected. So we prefer the term connected cars than autonomous cars. That covers all these other use cases. For example, wellness, monitoring lane drifting, monitoring fatigue, monitoring impairment of driving, or the mechanical functioning of the various parts, ECUs in the car. Or cybersecurity is another big area where edge AI can be of use. So there are a number of use cases that are short of autonomy that are going to be quite interesting, that we are actually having customers approach us to develop algorithms for. And I want to spend a moment here on privacy and security. When it comes to edge AI applications, there are very few places where privacy and security are more important than autonomous connected cars for obvious reasons. One of the aspects of edge AI, one of the reasons why you want to reduce and run your inference on edge, is because it's private and secure. The more data you prevent from sending to the cloud, the more privacy and the more security is going to be.
Right. So we are moving along nicely with our program, and the last point here, the last use case is utility grid monitoring. And Vishu, I want you to tell us. We've been talking about autonomous vehicle, we've been talking about the car industry, and obviously the rush to electric cars has created numerous challenges for utilities. They need to anticipate the load demand on the grid. Uh, and I've got a simple question. Why is it an AI use case more than a traditional, maybe rule-based application?
Yeah, that's a great question. When it comes to grid monitoring, the utilities are quite far behind the consumers on this side. The consumer adoption of electric vehicles and electric appliances, in fact, California here passed a law that all new homes built would only have electric appliances. So that rush towards energy efficiency and getting off the fossil fuels is fueling a consumer demand in these appliances that are electricity enabled. Now, the problem here is that the grids, the utilities are totally unprepared to manage their grids. If everybody in our neighborhood plugged in their electric cars at the same time, the grid would collapse. In fact, we are working with a utility in the northeastern US where they're just 4 households, if they are plugged in their EVs at the same time, their local transformer would collapse. So now the question is that how do you detect what appliance is plugged in? That's not a trivial problem to solve, and you cannot, even if you have, that would require every consumer to use smart plugs, smart outlets in their homes, which is not practical. So now your better option, or in most cases only option, is to sense these appliances, sense the energy usage using a machine learning approach. You could use even shallow learning approaches, but they're not as accurate as a deep learning, a machine learning algorithm to detect this appliance. And then beyond detection, you get into optimization, your energy source optimization. There, you could have a combination of rule-based approach and an AI approach. But the primary source of data itself, classifying these appliances, that's really better solved through an AI approach.
And presumably predicting patterns of behavior based on other external sources. So, if somebody drives in the drive having been away for 2 days, then you can probably predict that they're going to want to plug the vehicle in, or that type of behavioral input is I think pretty interesting to look at.
Absolutely.
And Matt, what has been your experience working with utilities?
I think it's it's maybe 2 steps before that in terms of the sophistication of looking at load balancing and all of those sorts of things. And the initial focus was just on smart metering, smart grid monitoring, and then getting into concepts of virtual power plants, i.e. People allowed to, or managing the relationship between electricity producers, consumers, because everybody's increasingly got their own production within their home. But more critically, with electric vehicles, everybody has a very large battery sitting on the drive, and actually, as well as being a challenge associated with that, because obviously as you mentioned, Vishu, there's that one example where if 4 people start charging their car, well, that's quite a challenging one. But the idea that you can plug in your vehicles into the electricity grid and allow the grid to draw down from your vehicle at the same time, well, not at the same time, but as an alternative to charging it up, and you permit that kind of behavior, well, actually that allows you to much more efficiently balance the production. Therefore, you can probably be more green with the production, probably cheaper with the production, because you're not having to fire up the less efficient plants at at peak times. So there are some advantages associated with that, and it tends to be those conversations. But I don't feel like at the macro level that the utilities or energy grids have actually got to grips with quite how big a drain on the grid the electric vehicles is going to be. I think we're still a ways off of that.
All right.
Right.
Thank you.
It becomes one giant problem when you consider everything that you mentioned. You got the various sources of energy from the grid point of view, and then we also have consumers having solar panels on their rooftop, and we also have what you can call like a cloud battery, right? There is a battery storage in every electric vehicle. So how do you optimize the charging and discharging schedule across all these sources of production and sources of draw? It becomes one giant optimization problem the AI is better suited to solve.
Completely, it's a systems optimization issue. So we tend to, we have all of these use cases that we talk about, and actually the system optimization one is the relevant one there, because it's a complex system, and therefore the application of AI to also some aspects of it absolutely makes sense.
All right. So we're getting at the end of our session here. I want to remind everybody that if you scan this QR code and enter your email address, you will receive a link with the forecast artificial intelligence market from Transforma Insights. Thank you, Matt, for sharing that with our audience today. I don't want to let you go, guys, before we touch on a very important point, which is the ROI of all that. Matt, have you been able to demonstrate the ROI of such technologies as IoT and AI?
Yeah, the interesting thing with a lot of these technologies is that the future's already here. It's just not very evenly distributed, as William Gibson said. And I actually have a lot of examples of particularly the use of IoT, a bit less so AI, but certainly some AI use cases, and certainly the ones that have the biggest impact in the near term for any organization out there thinking about deploying it will have already been rolled out by somebody. So on the AI side of things, I think about robotic process automation, just taking manual tasks and training an AI to replicate them and remove the need for it to be done manually. Things like processing invoices or reading data off forms, processing CVs as they come in, that kind of thing. Sorry, resumes for the Americans among you. That kind of process. And there are dozens, hundreds of examples of organizations that have deployed this kind of thing. One of the things we do at Transforma Insights is we have a database of case studies, effectively looking at who's done what and where. And you will tend to find that there's plenty of organizations at the bleeding edge who have tried this stuff, and there are tremendous learnings to be gleaned from that. So I tend to think, if you're an organization that hasn't got involved in IoT or AI, first things first, go look at what some of your bigger competitors might already have done and work your way through that.
And sorry, Matt, tell us, who are the early adopters and who are the stakeholders in such organizations?
Well, it tends to be bigger organizations is generally the trend. Stakeholders is an interesting question, because one of the key success factors, we've done a lot of work over the years with organizations that have been deploying proofs of concept and trying to work out, okay, we've done this proof of concept and it hasn't turned into anything, and that typically happens with 80% of projects, maybe a little less now, but it's around about that. And they want to know, okay, well, why does this not work? Why have I not been successful with this? And it tends to come down to the fact that proofs of concept are often just proofs of technology. They're not proof of the actual use case being working in a commercial or operational context. And so the starting point should always be, okay, I need to get everybody involved. I need to get buy-in from the relevant stakeholders within the organization who are going to be responsible for the impact that this has on finance, or the impact that this has on the people, or the impact that it has on our operations, which means really you need buy-in from someone fairly senior up in the organization, C-level executive typically, but I mean, it kind of depends on the size of the organization. That's for the more transformational use case. There are some which are much more basic, if you like, where if you can put together a business case, put it in front of the CFO and say this is going to save us 20% on our costs of processing invoices as they came in, as I talked about the RPA example, then fine, you'll get a big tick. But with the more transformational ones, it would tend to need that much deeper consideration of what the process and whole enterprise implications will be.
Right. And what are the risk organizations should be looking at when implementing such projects?
Well, first one is missing out is generally the biggest risk, to be perfectly honest. We've described IoT, and I guess by extension you can extend it to that to AI. That IoT is the competitive differentiator of the 21st century. By having a much deeper understanding of how people are using your products, or how the processes that you're managing are actually working in the real world, you can have a tremendous impact on everything about your operations, really. So as the slightly flippant answer is, the biggest risk is not doing it. There's not generally that much in terms of risks associated with doing it wrong, other than there are some quite high profile examples where organizations have decided to connect a product and have adopted some of the web practices and brought them into the physical world, and that hasn't worked particularly well. So there was examples of a company that made garage doors, and the people had to pay a subscription, and if they didn't, and their garage door was bricked. So almost literally it becomes a brick wall rather than a garage door. Or even someone like Philips. Okay, your lighting system suddenly requires an upgraded hub, or you get companies that make music systems. Historically, you would have bought your music system outright and it belonged to you, and you could do with it what you will. But suddenly you have a situation where you're having to pay subscriptions, or you're having to stump up money for what you thought should have effectively been yours. So there's been some bad practices in that space, just because organizations have misunderstood that Internet of Things is more about the things than it is about the internet.
Right. Vishu, at NeuTigers, what's your experience? What projects are getting the most tractions?
So what we are seeing is that more and more customers are focused on privacy and security, particularly with respect to where the data gets reduced. So we are seeing more and more edge inference-based use cases, whether it's monitoring driver wellness in connected cars and fatigue impairment, or whether it's in robotics, whether you are wanting to visually defect items or detect items. So these are where we see more of adoption in terms of AI, is where the data can be reduced and processed on the edge.
Okay, great. Well, Matt Hatton and Vishu, CTO of NeuTiger, thank you so much for your time today. I don't know if you want to add anything, but I think we covered greatly all of our use case today. Thank you again. Thank you, Matt, for sharing this study, and I will flash the QR code one more time for people to download the report if they are interested. Thank you for your time today, and goodbye.
Thank you.
Thank you. Thanks for your time.